So students will discuss a very important topic, which is light. It must be a familiar term with you. Light basically is an electromagnetic radiation. You must have heard about various electromagnetic waves, right? Like X-rays, ultraviolet radiations, then visible light, then infrared radiations, then microwaves, radio waves. These all are the electromagnetic waves which forms electromagnetic spectrum. So visible light, or simply light, is a small part of that electromagnetic spectrum, and it is the only part which is visible to us. The rest of the electromagnetic waves are invisible to us. So light is an electromagnetic radiation. It's basically a form of energy. You will study in higher class that it contains packets which are known as energy packets, which are known as photons. Photons, P-H-O-T-O-N-S, photons. So now, from your level point of view, light can be defined as electromagnetic radiation. It is a small part of the electromagnetic spectrum which is visible to us. Light obviously is a form of energy. Now, in the first topic, we will discuss reflection of light. Now, when light is incident on a substance, then what happens is a part of the light may get reflected, it can get bounced back into the same medium, another part may get absorbed by that particular substance, and the rest may get transmitted. So, when light is incident on a substance, three things can happen. Either the light can get reflected, it might get absorbed, or it might get transmitted. So here we will be discussing reflection of light. Now light can be reflected only through those surfaces which are smooth, which are optically plane, like plane mirror. A simple glass can be made a plane mirror. The process is we have to deposit a fine layer of silver on its surface. So that will act as the back surface. So the front surface will reflect light when light is incident on it. So let's start with the definition part first. Reflection. It is basically the bouncing back of light into the same medium. Now look, plane mirror, it will be represented by this. This is a straight line. This represents the back surface, which is deposited with fine layer of silver. So this one will be the reflecting surface. This is the reflecting surface. Now, when light is incident, this is a ray. When light is incident on a surface, say a plane mirror, then it will bounce back into the same medium. Suppose it is coming from air, it will bounce back into the same medium. Right? So this is reflection. So reflection of light is basically the phenomena of bouncing back of light into the same medium when incident on a surface. And one thing to be noted is that the incident ray, the reflected ray, both are traveling in the same medium. So during this phenomena of reflection, there won't be any change in the wavelength, in the frequency, in the speed, or in the energy of the light. All these things will remain constant. That is, the wavelength, which we represent by lambda, the frequency, which we represent by nu, the energy, the velocity, all these physical quantities of the incident ray as well as the reflected ray will remain same. So now, before we discuss further, we need to understand some basic terms and definitions. So as I stated, a plane mirror is to be represented by this. This is the reflecting surface and this is the back surface. Now whenever reflection is studied, we need to draw a normal. Now normal is an imaginary line which is perpendicular to a given surface. Suppose at this point we need to draw a normal. So what we'll do is we'll draw a perpendicular. So any imaginary line perpendicular to the surface is known as a normal. This is normal. And it has to be represented by dotted lines. It's an imaginary line. Suppose ray gets reflected at this particular point, which is A. This is incident ray. This is incident ray. The angle which the incident ray makes with the normal is known as angle of incidence. Now we have discussed when the ray of light get incident on a surface, it will get bounced back into the same medium. So it will bounce back into the same medium like this. This is the reflected ray. This is the reflected ray. The angle which the reflected ray makes with the normal is the angle of reflection. So this is incident ray, this is normal, and this is reflected ray. This is absolutely mandatory to indicate these arrows, which will indicate from which direction the ray is coming, and after reflection, it is going in which direction. So arrows, it's absolutely mandatory to represent it in the ray diagram, right? So once we have understood these terms, we can now concentrate on the laws of reflection. So first law. First law of reflection, there are two laws which are collectively known as laws of reflection. The first law simply states that the angle of incidence is equal to the angle of reflection. Always, wherever reflection takes place, either reflection of sound or reflection of light, laws of reflection are always valid. So the first law states that the angle of incidence is always equal to the angle of reflection. It can be experimentally verified. It's actually in your experimental, practical syllabus. You can verify this with the help of a laser light or with the help of a wooden plank along with the safety pins. We will do it in the lab. But for now, the theoretical first law states that angle of incidence is always equal to angle of reflection. Second law states that the incident ray, the reflected ray and the normal all lie in the same plane. All lie in the same plane. The incident ray, the reflected ray and the normal all lie in the same plane. You can very well observe incident ray, reflected ray, normal all are lying in the plane of this whiteboard. So nothing new in it. If you draw this ray diagram on a paper, then all these three will lie on the plane of the paper. So they are coplanar basically. So two laws of reflection. First law states that the angle of incidence is always equal to angle of reflection. Second law states that the incident ray, the reflected ray and the normal all lie in the same plane. Now we will discuss some special cases as well. Look, this is the plane mirror, this is the normal. This is a very, very important concept which I am trying to convince you. Now, suppose this is the incident ray, this is the incident ray, this is the incident ray. So the incident ray is coinciding with the normal. So what would be the angle of incidence in this case? Angle of incidence in this case would be equal to 0 degree. Remember, angle of incidence is the angle which the incident ray makes with the normal. So here, incident ray and the normal both are coincident. Therefore, the angle between them, which will be the angle of incidence, is 0. And as per the first law, which will be equal to the angle of reflection. So since angle of incidence is 0, therefore angle of reflection should also be equal to 0. Therefore, in this case, the reflected ray or the ray after getting reflection will retrace its path in the opposite direction. So it's a very, very important concept. Here the angle of incidence is not 90 degree. Angle of incidence is 0 degree. Therefore angle of reflection is also 0 degree. This is the reflected ray and this is the normal as well. The reflected ray and normal, they are also coinciding. Right? So for normal incidence, normal incidence means when the incident ray is parallel or it coincides with the normal. That is known as normal incidence. So for normal incidence, the ray after suffering reflection, it tends to retrace its path in the opposite direction. So angle I is equal to angle R. That is valid. So remember, be cautious. It's not 90 degree. Angle of incidence, angle of reflection is not 90 degree. It is 0 degree over here. Right? So wherever reflection takes place at a point on a surface, the laws of reflection must be valid. There are some basic concepts as well. Like before we start with the image formation in the case of a plane mirror, you need to understand the type of the images. We will encounter about a real image, the virtual image. So you need to understand these very basic facts. Let's bring out some essential point of difference between real image and virtual image. Look, as the term suggests, real image, the actual image which can be obtained on a screen, that is known as real image. So any image which can be obtained on a screen is known as real image. Suppose it's a mirror and its image of the object is formed in front of the mirror. So in case you place a screen over here, the image of that object can be formed on that screen. So that will be a real image. Image that can be obtained on a screen is said to be real image. While on the other hand, virtual image. Now virtual means, little meaning of virtual means imaginary, right? Hypothetical. So this is the image which is imaginary, which can't be obtained on the screen. For example, plane mirror, which we very often use, daily use plane mirror. In such a case, if we stand in front of a plane mirror, our image is formed behind the mirror. So it can't be obtained on the screen. It can't be obtained. So that image is virtual. Virtual means imaginary image which is obtained behind the mirror, which can't be obtained on the screen. So in case of mirrors, if the image is formed on the same side as that of the object, that is in front of the mirror, then it must be real. And in case of mirrors, if the image is formed behind the mirror, then the image can't be obtained on the screen, and accordingly that will be virtual image. So these are some basic concepts which you need to understand.